Hello and welcome to the beginning of a new tutorial series. This time we'll be creating the world map system that was showcased on my channel a couple of days ago. So this will include features like placing markers, undiscovered areas, zooming, adding fast traveling points and much more. Additionally, the map will be drawn by hand and not rendered in-game. If you want to generate your map using a camera in-game, we did that for the minimap that was part of the Quest tutorial series, so you might want to have a look at that. But now without further ado, let's get started. To create our project, we'll be using the latest version of Unreal Engine. Currently that's 4.19.2. If there are any upgrades during the course of the series, of course we will update. So let's hit the launch button and give it some time to load up. Then we will head over to New Project, to Blueprint, and the template we will be using as a base will be the third-person template. Desktop console and maximum quality. We want to include starter content, so we've got access to a couple of visual effects and materials. So let's select with starter content. Then you can give your project a name. I'll just call mine map_tutorial. And then we can hit create project and resume once the engine was done loading. Okay, our project was created properly. To keep everything organized, we will head over to the content folder and create a new subfolder here, which will store all of the assets we create for our system. So let's just call that world map system. And because we'll be working mostly inside of this folder, we will right click and set color to something like a bright yellow or orange. So we directly see this folder. Let's go in there. And for our system, we will need a couple of icons. So let's create a new folder and call it textures. And go in there. Like with all of the other series, I have prepared an asset pack for you, which will contain all of the icons needed for following along with me. Link for that will be in the video description of every episode of this series. So just hit that link, then hit download, and you will get a .raw file. So extract that. In the folder you will have 3 different icons. So simply grab all of these 3 icons and move them into the textures folder of your project. Alright, if you've imported all of the textures, you will have the icon marker, icon player, and icon travel point. Let's select all of them using the Shift key. And then we will go to Asset Actions and to bulk edit via property matrix. So that way we can change the settings of all of them with just a few clicks. Let's go to level of detail, and all of these textures will be used on a user interface only. So you can go to texture group and set that to UI, and finally go to compression setting, and also set that to user interface 2D. Then you can hit Ctrl and S to save all of them. And if we just have a look at our icon marker, you can see if we zoom in that looks very blurry. Go to texture and hit that little drop down. You will get a filter, and here you can select nearest. So that will restore its crisp look when zooming in and out. We want to do the same thing for our icon travel point. So filter nearest. With our icon player that doesn't really work well because some parts of it are semi-transparent, and usually the filter nearest doesn't work well with round shapes, which our player icon actually is. So here we will keep it the default. Now with the textures imported, let's set up a very basic level for testing purposes. First off, we will select all of the elements here that we don't want to keep. So the boxes, static meshes here, and hit delete. Do the same thing for stairs and the text. Then we want to increase the size of our levels. So let's select our floor here. Currently its scale is set to 0.75 in X and Y. Z doesn't really matter. Let's say we want to double the size. So set it to 1.5 in X and 1.5 in Y. Of course, now the walls are no longer aligned. So we want to select a wall. And here the scale is set to 30 in X. So let's also double that to 60 so that it fits. And let's remove the other walls for now. Now we want to move that one bit to the right so that it fits. Good, somewhere here that should be fine. We also need the other 3 walls, so let's hit Alt and drag out a copy here to the very left, and also move that to align the end of our floor here. Then for the other 2 sides we will also drag out a copy, but this time we'll go into rotation mode, and on the blue axis here, which is the Z axis, we will rotate it by -90 and then move it to the right until it connects our 2 other walls. And once that is done, we need the last copy, so hit Alt and drag it out and adjust the location of that until it fits. Alright, that's looking okay. The idea here is to design a very simple jumping parcours. So let's make the ground water. To do that, simply go to Starter Content, Materials, and if you scroll down here, there should be the m_water ocean. Let's drag and drop that onto our floor. Alright, now we've got water here. And for the platforms to jump to, we'll simply go to third person, meshes, and use the bump_static mesh here. Then you can just play around with the size of that to design your level. Alright, I will add some more elements here to fill out the whole level and speed up the process for you. Feel free to pause the video here and resume once you're done designing your level. Alright, when you're done designing your level, you will probably get a red message here saying lightning needs to rebuild. So that way shadows will be calculated again. So just hit build and wait until everything is done there. Now our level is looking very good. Note that I also moved the starting point of our third person character to the beginning of the parcours here. To make our map work, we need to be able to know where the level here starts and where it ends. To define this, you only need 2 points in your level, which is the upper left corner of it. So that would be somewhere here, and the lower right corner around here. With these two values, you can calculate both the width and height of the whole level without having to know about any other locations in your world. And for that, we will use what is called a target point. So here under basic, just search for target point. And basically that is just an actor that you can drag somewhere in your world to define a specific location. So let's drag one target point in here, hit F2 to rename it, and let's call that upper left. We have to move it to the corresponding spot in our level, of course. In 3D, that could be a bit tricky. So here on the very left side of your viewport in the upper left corner, where it currently reads perspective, let's left click that and change it to top. So now you got a top-down view of your level in wireframe currently. You can also set that to unlit or lit, but wireframe will be fine for us. And now you can only move your target point in X and Y and no longer in Z, which is perfect for us. And it's very simple to just drag it over and place it at the very upper left corner here. Then we can hit Alt and drag out another copy, rename this to lower right, and then of course move it down and to the left until we hit the lower right corner, so somewhere here. You can go back to perspective mode. That is everything we need in our level for now. So let's go ahead and create some of the map logic already. The idea is that we will make that very similar to the radar system we worked on lately. So the whole map logic will be handled by a single actor component, which we will later attach to our third person character here. Let's create a new folder in the world map system folder called actors, and go in there. Then we will right click, create a new blueprint class of the type actor component, and we will call that BPC for blueprint component underscore world map. And let's also open that up. Like I said, the world map needs to know about the 2 points, so the upper left and lower right corner. Otherwise it wouldn't be able to figure out the width and height of our map. So let's add a variable and call that upper left corner. The variable type here will simply be a target point object reference. And so that we can set it from our level, we want to make it editable, exposed on spawn. So this will be one of the key settings for our world map. To show that, we will also put that in a category. So simply type in settings here and hit enter. And here you see that appearing. Create another variable of the same type called lower right corner. And also make that editable, exposed on spawn. Once you've created your category, you can simply hit the drop down here and select it. To be able to use these variables, let's compile and save. And let's add the functionality to figure out the dimensions of our world. So let's add a function called getMapHeight. Like the name already suggests, this will only get a value. So we can make it pure and it no longer needs execution pins. And of course we need to return the map height. So let's give it an output of type float called out. Save. To get the map height, you simply get your lower right corner, get the actor location of it, and then we need to break that. So this way it will be split up into X, Y, and Z. Z isn't interesting for us at all because we're trying to project the world onto a 2D map, so depth isn't needed. And for height, we actually have to use the X value here. So let me very quickly show you. In our level, if we just take a look at our third person character, location in X is currently minus 2890. And if we go into the top down view and move him up, you can see that this value here changes. So changing X means moving up and down, and changing Y means moving it to the left, to the right. Okay, let's return to our world map. So like I said, we have to use X, and from that we have to subtract the X of the upper left corner to get the amount of Unreal units that is between those two corners. So get actor location here, and also break it. Then plug in the X. Just to make sure that the result here isn't a negative number, we will call the absolute float function and plug that in for out. File save. Of course, we need to do the same thing for width. So get map width. This can also be a pure function, and give it one output of type float called out. Then get your lower right corner, get actor location, break it. And this time, like I showed you, we have to use the Y. So again, we will subtract the float, copy get actor location and break vector, plug in the Y and use the upper left corner. Hook that up to the target. Again, we will call absolute and plug that in for the output. All right, let's compile and save. So these are the two functions we need to figure out the dimensions of the whole level. The problem right now is that all of the locations in our world, for example, the location of our character here, are not based on the two corners. So if we were to move our character directly onto the upper left corner, for example, his location would be exactly these three values. However, we want our level to be based on these two corners. So we want to say that the upper left is the origin of our world. So if our player is standing directly on the upper left corner, his location should be 0, 0 instead of what is in here currently. So let's add a function for that, which we will simply call convert location to map location. And this needs an input. The type here will not be float, but a vector. Let's call that location. It can also be a pure function, and it needs one output, but this time we'll not use a common vector, but a vector 2D, and let's call that out. Like I said, we don't care about Z when dealing with a 2D map, so a vector 2D is fine. Let's right click the out and split the struct pin. And now we have to figure out the out X and out Y. Let's start with the out X. For that we get the in location and break it, and then use the Y. That's just something to keep in mind. The Y of a 3D vector actually is the X of a two-dimensional vector. And from that we have to subtract a float, then get the upper left corner, get actor location, also break it, and hook up the Y. Then we will call absolute again, plug that in for X. And for Y it's basically the same thing, so we get the X here and subtract the X of our upper left corner, then call absolute and plug it in for out Y. So these are all the functions for this episode. However, our world map needs to know about the player that it's created for, so we can get his location, project that onto the map and so on. So let's create a variable, call it player. And the type here will not be the third person character, but we will simply use the character class, this one here, and make it an object reference. That is because the character class is the base class for the third person character, but also for the first person and for all of the other characters in the other templates. So by using the base class here, our system is not limited to the third person template. and can later be migrated onto first person or top down, something like that. This variable will only be used internally, so we can make it private. And of course we need a way to set it. So let's hop over to the event graph and let's add a custom event called initialize map. So when this map should start functioning, we need to tell it about the player, add a new parameter called player. And here we have to use the same variable type, so a character object reference. Let's check whether the player we got here is valid. If it is valid, we can simply set our internal variable to it. If not, there is some kind of issue with the system. So to let the developers know, we will print a string and type in something like error, player is not valid in bpc_world map, exclamation mark, and let's say duration of 5 seconds and give it a red text color to show it's an error message. Right? That's it for this event for now. We will come back in here in later episodes and expand the functionality. So let's compile and save. And we need to attach that to our player. So open up your third person character or whatever template you're using. We can remove the touch input here, don't need that. Same thing goes for our gamepad input and VR stuff. Let's add a component and look for the BPC world map. You can hit F2 to rename that to something like player map, or whatever name you want to use. And then let's go here and implement the event begin play. Then we will simply get the player map and initialize it. We'll be asking you for a player. We made that an input. That will simply be self. Right now you wouldn't see anything working because there is no visualization to our map. But let's just test whether our functions are working. So off of your player map, let's get the width of the map and let's get the height. Then we will print a string and look for append string. A would be something like width, that white space. Then we will connect the width to B, add a pin, add another white space, then height, add another pin, and the height will go into D. Then hook that up to the in string. Say we'll make that green for a duration of 10 seconds. And now if we were to go into a new editor window and play, you will see that the width and height both read 0. And it will also give you error warnings. The reason for that is that our player map still needs to know about our 2 corners in the game. And to set it, we need to minimize our third person character, select our character in the level, then in his components we can select the player map, and now we get access to the upper left corner and lower right corner. Here you get a drop-down menu where you can simply pick all of the target points in the level. So let's select upper left here and lower right. Then if you save and play, it will read a width of 5900 and the same thing for the height. Okay, let's also check whether converting a location to a map location is also working. So let's open the blueprint editor and let's say on event begin play, we want to set a timer by function name, looping, and let's say every second. Then we'll simply create a function, print location, and get your player map, call convert location to map location, and we want to give it the player location. So get actor location of self and plug that in. And then off of your out, we can simply convert that to a string and call print string. Maybe a duration of 1 second. Plug that in for the in string. Go back to the event graph and for the function name type in print location. Alright, if we compile, save and play, now it should do that every second. Alright, currently doing that. So the Y is set to 5400 right now. If we go to the very lower side of the map, it should be somewhere near around the 5900, which is the total height. Of course, we can't reach that value exactly because the walls are between that and the collision sphere of a character. But you can see that the value is getting closer to 5900 when we're moving downwards, and if we move upwards here, it will get closer to 0. Alright, same thing goes for X. So currently, the smallest value we can reach here is something like 37. And if we move to the very right side, that will increase until it's somewhere near around that 5900, which is the total width of the map. Okay, so all of that is working perfectly. The print nodes and the timer were only for debugging purposes, so you're able to check in your project whether the functions are working properly. You can remove them now because we no longer need them, and also remove the print location. Then hit compile and save. And that's the end of this episode. In the next one, I will show you how you can accurately draw the map for your level in an image manipulation program like Photoshop or GIMP. Then we want to display that in-game and also update the position of the player when he moves around. See you then.